Cardiovascular disease is the leading cause of death, being deadly and killing 33% of America's population. This disease consists of a wide range of conditions which affects one's heart. Cardiovascular disease includes blood vessel disease, such as coronary artery disease and heart rhythmic problems. These conditions generally narrow or block blood vessels that can lead to heart attack, chest pain, or even stroke. Early detection of cardiovascular disease is necessary because it can be the difference between one's life and death. In addition, some important biomarkers of cardiovascular disease include high glucose levels, high blood pressure, high cholesterol, and high body mass index. Now, these factors lead to cardiovascular disease in different ways. Let's start off by looking at high glucose levels. High blood glucose levels can damage your heart by destroying the nerves and vessels. Also, more glucose in the blood is affiliated with an increased amount of contractions and weaknesses in the heart. High blood pressure causes the blood vessels to wear away because of the increase in collisions. This leads to the hardening of arteries or atherosclerosis and death of blood tissue, as blood is not reaching the heart. Not only this, but cholesterol does the same, as plaques are formed, which harden the arteries. This is what is shown in the picture on the PowerPoint. An increase in BMI is usually linked to many other factors leading to heart disease, including diabetes and high blood pressure. So this explains why BMI and cardiovascular disease have a direct correlation and causation. From this introduction, one can see how important finding an early diagnosis for the disease is, as letting it continue will lead to many injurious effects. To figure out a method to diagnose cardiovascular disease, machine learning was used. Machine learning is a subcategory of artificial intelligence that provides a way systems can learn and improve without being explicitly programmed. To do this, the computer looks at certain types of trends from observations in data. The type of machine learning used for this project is supervised, applying what one has learned in the past from a training data set to new data, or the testing data. The computer uses what it has learned to make predictions about its output, and the accuracy is determined. There were two machine learning algorithms in this project, logistic regression and a neural network. Logistic regression is a statistical method for analyzing a data set in which there are one or more independent variables that depend on an outcome. This outcome is usually binary, or the likelihood from 0 to 1. Thus, in more practical terms, when a testing data set is added to a program, the output is a number that follows a trend on the logistic regression graph. Nevertheless, logistic regression has many uses, as it is a convenient way to measure accuracy, is efficient, and can be used in many different applications. However, because of the simplicity of the program, it can't handle a large number of features well and relies on a large training data set. More specifics of logistic regression and ways the negatives were addressed will be accessed later on. A more complex algorithm is neural networks, as they are a series of endeavors that recognize relationships in a set of data. The whole goal of a neural network is to act like a human brain. The connections made from the training data set predicts the most likelihood of an output of the testing data set. In the picture, you can see how an input layer is added and hidden layers are present. These hidden layers have many functionalities, which help in drawing conclusions and will be emphasized later as they come in many different forms. The output layer represents the network's final conclusion. Even with the advancement of neural networks, flaws are still present. The flexibility, speed, and adaptation is contrasted with its expenses and need for a lot of training data. However, the reason why logistic regression and a neural network were used as algorithms is because they were ideal for this dataset. A dataset from UCI Machine Learning Repository was found as the data contained about 4,300 samples with 10 different features. Some features include BP medicines and the prevalent stroke. An output value of yes or no for cardiovascular disease was also found. with 0 being no and 1 being yes. In machine learning, features are the specific characteristics of a phenomenon being observed. However, as mentioned, logistic regression cannot deal with many features. Thus, the only main characteristics used for early diagnosis were the total cholesterol, the systolic and diastolic blood pressure, BMI, and glucose levels. This also helped with increasing the accuracy, as data with many attributes leads to overfitting, or, in other words, modeling a dataset with too much detail leading to faulty guesses. Not just this, but some of the values for these attributes were not recorded, such as the not applicable sign here. So, the 4,300 samples were reduced to about 3,700. This was still large enough to address the main flaws of a neural network, its need for a lot of training data. In my next video, I will be talking about how I actually made the logistic regression model and later the neural network. I hope to see you soon. Thank you.